Greetings, folks, and welcome to today's show. As you know, we have an abiding interest in education, and we always try to introduce you to the leadership and the several bits of education we have here. Our guest today is Dr. Mark Whorton, who is the new executive director at UTSI. Started back in July, so he's fairly new with us. He's coming to us from Huntsville, and for family considerations, he's not going to move, so he's going to be commuting between here and Huntsville for the next year. We probably don't envy him that direction, but the family is important also. So welcome, and give us a little, we're going to go over your background and credentials, what you've been doing for the last, you say 29 years, but let's begin at least with the educational part of it.
Well, good morning. I appreciate the opportunity to be here. It's nice to be introduced to the community, and I'm very excited to be a part of the University of Tennessee and here at the Space Institute. I have a background that some of the community may not appreciate so much. I have 2 degrees from the University of Alabama.
Well, I'll appreciate it.
Well, good.
Because I'm an alum also.
Well, fantastic. And I earned a PhD from Georgia Tech in aerospace engineering. And so for the first 20 years of my career, I worked at the NASA Marshall Space Flight Center in Huntsville, Alabama.
20 years, okay.
And thoroughly enjoyed that career, did a lot of interesting things, worked on some space station payloads and some space shuttle payloads, and worked on developing the new crew launch vehicles that we hope to send crew to Mars on. And then for the last 7 years, I've been working in industry at Teledyne Brown Engineering in Huntsville, where most recently I was the chief technologist. And of course, that was prior to coming here in July.
All right. Okay, well, we'll go over some of that a little more in detail, but meanwhile, let's take a short commercial break, folks, and we'll be right back.
All I have to do to think about what I was physically before and what I am now, and I don't ever want to go back to that original situation.
The overall mission of the rehab team is always what is best for the patient and how we can facilitate maximum potential from every resident.
Well, the most important thing to me is that I'm allowed to do whatever I want to do, you know.
Everyday Miracles, Life Care Center of Tullahoma.
Tired of paying for monthly telephone service, expensive long-distance bills, and all those crazy taxes? Are you sick of spending money on telephone equipment, maintenance contracts, and service calls, all for a phone system that shackles you to 100-year-old technology and your desk? Stop it. It's time to ship your phone system to the cloud. What can the cloud do for you? Bring together remote offices, workers, and employees in the field. Make sure that you'll never miss calls by delivering them to multiple devices. Modernize faxing by allowing multiple faxes to be sent and received at once. And deliver to email. Get your voicemail messages instantly through email too. And take advantage of an endless supply of customizable features. Host My Calls can deliver the cloud. All of this technology with low upfront costs and not 1 penny in capital expense. It's time for a phone solution you'll truly love from Host My Calls. Call the number below.
We're back, folks, and we're talking today with Dr. Mark Whorton, who, as of July the 8th, is the new executive director at UTSI. So we are going over his background and what he's been doing for a number of years. And I might mention also that he is a fellow of the American Institute of Aeronautics and Astronautics, or maybe I have those backwards. And also, I believe, on a member of the board, at least a regional board somewhere. Yeah. Okay. All right. Let's talk a little bit more about your background. One description I saw said your technical focus has been dynamics and control of vehicles, spacecraft, and space structures. That sounds like a lot of stuff.
Well, it is, but I think early in my career I was interested in some really challenging problems at that time. When I first joined NASA, there was a lot of interest in building really large structures in space, and we were talking about these very large solar collectors that would beam power down to the Earth, and really, really large space stations, very large telescopes that we could peer into the edges of the universe with. And so some of the challenges of those would be how do you accurately and precisely orient a large object in space when they're very, very light and flimsy and flexible. And that's kind of a problem somewhat unique to space systems.
Orient meaning what do you want it to point to?
Yes, what you want it to point to, yes.
Right.
When you launch something into space, you have to be very, very conscientious about its weight, its mass. That's the number one driver. And so lightweight structures tend to be very flexible and flimsy. And so you could think of like trying to point, a spaghetti, a piece of dry spaghetti versus a wet piece of spaghetti. It's very flimsy.
I kind of grew up alongside the Atlas and Centaur projects, so you talk about flimsy structures. There was a lot of controversy over that one.
Well, you wouldn't tend to think of those as flimsy, but they are, and that is one of the more recent challenges we've been working on. Is how
there's a balloon just pressurized.
Exactly. Yeah. So my early research focused on things like the Hubble Space Telescope. A lot of people don't know this about the Hubble telescope, but everyone knows about the mirror problem, right? The images that were out of focus because of the mirror. What people don't know is there was also a vibration problem. And the Hubble telescope was designed to be able to point to a dime from 200 miles away. So you can imagine if you had a gun and you keep the crosshairs of your scope on a dime from 200 miles away. That's what the Hubble telescope has to do. But it has to do it for 30 days, uninterrupted. And so that's a pretty significant challenge. So when we talk about orienting things in space, that's the kind of challenge. So what happened is every time the Hubble telescope would go into the shadow of the Earth, it would the temperature would change by about 300 degrees, and the materials would shrink. And then when it would go back into the sunlight, it would heat up about 300 degrees, and it would expand. And this caused it to pop. And when it would pop, it would cause the mirror to wobble just a little bit, and it would lose lock.
Pop, but nothing exploded.
No, just like you hear when your heater comes on in the house, you hear pipes pop. Right. It's exactly that. So we had to deal with the challenge of making the Hubble telescope meet its objectives. When fortunately no one in the press knew about that problem, though. So that was an early example of research that I wanted to work on. How do you address the challenging problems of pointing space structures when they're very flimsy and hard to test on the ground?
And dealing with quite variable temperature environments. Okay. You have currently, most recently, been working on an Earth imaging platform?
Yes.
Which is
going to launch, we believe, in March. This is a project I worked on with Teledyne Brown Engineering for the International Space Station National Lab Office. Those are sort of the organizations that sponsor it. So we came on the idea about 5 years ago that a really good use of the International Space Station is for looking down. A lot of people have built payloads to study, processes in microgravity, what happens to the human body on long duration exposure to space. Those are really important things. But it turns out the space stations are a really good platform for studying and observing the Earth. And so we decided to build this pointing platform. It's about the size of a card table. And it points very, very accurately at a point on the Earth as the space station passes over. Now, the space station is about 250 miles in orbit, so it's fairly low for a satellite, which means it's a pretty good place because you're closer to the Earth than a lot of other satellites. So you can use smaller telescopes to
if
get
it's
good
that close,
resolution.
how have we kept it from coming back into
Well, that's
the...
a good question. Really good question, because it's lower than most satellites are that need to stay up for 10 years of operation. You typically, I'm going to mix units, forgive me, you typically have to be above 600 kilometers or so in order to stay in orbit for many, many, many years. And so most of the satellites are 800 kilometers, 1,000 kilometers or higher. But the space station has to be low enough that the space shuttle could get to it. And the space shuttle didn't have the ability to get to those high orbital altitudes. So it's low enough that it has to be reboosted probably every 6 months or so. And so you can watch the orbit of the space station drop over a month or 2 or 3 because of the atmospheric drag.
Is that boosting is it doing its own boosting?
Well, we use Russian rockets right now to boost it. So the Russian rockets that take the crew up, Russian rockets take cargo up, and then they reboost it as well. I'm not sure if the U.S. commercial rockets are going to reboost it or not. I don't think so right now. There's plan for that. I don't know for sure about that, though.
Huh.
So we actually have Russian rockets that will raise the altitude of the space station by about 50 kilometers, every 6 months or so.
Yeah, and we've also been relying on the Russians to get back and forth up there. I don't know how we wandered into that.
But the pointing of the pointing system is an interesting problem, because you've got to think of the space station. It's traveling 17,000 miles per hour. And to be able to image something on Earth, it's equivalent to, I've used the example of driving through Chicago at 17,000 miles per hour and taking a picture of a building in St. Louis. That's basically the problem you have when you're taking pictures of the Earth from space. It's really not as hard as that sounds, but that's effectively what we do.
Okay. All right. And you had a season at Tennessee State.
Tennessee State, yes. That was part of the NASA Administrators Fellowship Program, where NASA researchers go to universities, and university researchers in an exchange way come back to NASA centers. So I was a visiting faculty member and an adjunct faculty member at Tennessee State for 2 years. Tennessee State's located, of course, in Nashville, and they have a really strong capability in what's called automated astronomy, again astronomy. They have a group of telescopes that are at the time they were called robotic telescopes. You program them ahead of time and they will move it from target to target throughout the night and do scientific observations. And so we were working with them, and we were working on an interesting project actually in Hawaii on a telescope that I believe has begun construction now. It was called the Giant Segmented Mirror Telescope at the time. It's called the 30-meter telescope now. So it's much larger than any other telescope on the ground. And the issues there are that the structure is so large that the wind moving over the mirror causes the mirror to vibrate. And it's really kind of similar to what we were talking about with the Hubble Space Telescope, but this is actually a telescope on the ground. So it's understanding how the structure responds to the motion of the wind moving over the telescope, and then how do you cause the mirrors to move and react fast enough to essentially negate the effect of the mirror motion due to the wind. So it's essentially to make a quiet ride for the light as it moves through this telescope that's vibrating in the wind.
I guess we don't need to know how you do that, do you? That's probably over our head anyway. Okay. Then you were into something called bathymetric mapping systems and camera engineering and things like that.
Right. The last 2 years in Teledyne, I had a responsibility as president of a smaller company we acquired called Optech, O-P-T-E-C-H. And this is a company that makes LiDAR instruments. Now, LiDAR is an instrument that works by, much like radar, but it uses a laser. And you focus a laser and you shine the light, and you measure when the light returns. Now, you know the speed of light, and if you measure how long that pulse has traveled, you can tell the distance to the object it reflected off of.
Right.
And if you think like a garden hose with water drops, this laser shooting out individual pulses of light, if you spray the wall with these light particles, then you can build up a map of the wall from measuring the return of each one of those light pulses. So this is the way a LiDAR instrument works. They're standard instruments for mapping and surveying in use today. But what we did was we put them in airplanes and flew along the coastline, and you would measure the reflection off the bottom of the ocean, and you could get a map of the surface beneath the bottom of the ocean beneath the surface of the waters. And it's used for Coast Guard, for engineering projects. Where do you need to do dredging, and those kind of projects along the coastline.
Pretty handy for submarine users too.
Very.
I would think, yeah. All right. Well, let's see. You've most recently been connected with Earth imaging, ground-based telescopes, camera engineering. I guess we talked about that. I have a kind of a interesting question there, which I'll ask you when we come back. We're about to take a break.
Trucks, and more trucks. Keith Barnett here with the Russell Barnett Automotive family, and we have your next truck. From the Ford F-Series, the Ram, Chevrolet, or the GMC, then look no further than the Russell Barnett family. With over 350 new and pre-owned trucks to choose from, now is the time to buy. Stop by one of our 5 locations. That's Russell Barnett Chrysler Dodge Jeep Ram, Chevrolet GMC, Ford of Winchester, and Russell Barnett Ford and Kia of Tullahoma, or visit us on the web at russellbarnett.com. Why buy anywhere else?
It's time for every family and business in Tullahoma to go green and recycle. Tullahoma Public Works makes it simple and easy to recycle. Just place your recyclable materials, paper, plastic, aluminum, and cardboard beside your garbage container on the same day your garbage is picked up. Your recycled materials don't have to be in a fancy container. Recycling is not only the right thing to do, it makes sense. Recycling pays. Paying to bury our garbage costs each of us. Please do your part. Let's go green, Tullahoma, and recycle.
It's your trademark. That's something special everyone knows and remembers. It's your thing. It's made holidays special for decades and summers unforgettable for the entire neighborhood. It's made everyone laugh every single time. Don't let illness or injury keep you from doing your thing. The rehab team at Life Care Center of Tullahoma is ready to help you live well.
I'm meteorologist Leland Statham from the News Channel 5 Weather Center. Look to Jim Fuller and crew for local news night here on Channel 6.
We're back, folks, and we're talking today with Dr. Mark Whorton, who is, as of July the 8th, is the new director of at UTSI, executive director, I should say. And so we're happy to have him on and to be able to familiarize you with him. He's going to be significant for us for a while. When we broke, I was about to mention the fact that you have done what sounds like camera work and telescope work, and I was wondering if you're kind of into that, but I believe there's another aspect of it that
right.
rather than the actual camera engineering.
Correct. I know enough about cameras to be dangerous. My work really is on how do you orient the camera to take very still, pristine photos. Sometimes you get down into the camera, like the telescopes, when you have separated mirrors. Sometimes our work involves how do you control and orient the components inside the optics, but the electronics of the camera, the focal plane arrays, the optical system layout and design is really not my area of expertise.
Yeah, okay. You just want to control what the camera's doing.
Exactly.
Huh? Okay. Well, with that, folks, let's change our direction a little bit. Instead of his background, let's see if we can ask him where he's going. Your background is not that heavy in academia, which comes as a little bit of a surprise. Is there something involved in your background that has an influence over where UTSI is headed?
Well, absolutely it does. Academics is very important to me. I have always sought, since completing my doctorate at Georgia Tech, to maintain an academic research engagement. And so throughout my career, I always was involved in mentoring PhD students. I pretty consistently sponsored graduate research and worked with university professors at multiple universities throughout, and I've maintained a publication record of that work in order, largely because I wanted to invest in the continuing development of research, but I also wanted to maintain my own proficiency. So rather than moving into program management or something like that, I always wanted to maintain active research programs so I could continue to be proficient and cognizant of the state of the art. So academic work and research, university research has always been of a very high priority to me. But I do bring some interesting things to the university. The University of Tennessee Space Institute has a very long and proud heritage in supporting the Arnold community, the Arnold Engineering Development community, right. And we want to maintain that and continue that. Having been a civil servant for 20 years, I understand very, very well what it's like to be on the other side of the gate. I know what it's like to be a steward of the taxpayer investment. I know what it's like to have a mission that must be carried out, in the most cost-effective way with taxpayer fundings in the development and implementation of technology. So I understand very well the mindset of our primary partner and customer here in the Arnold community. I also understand how to generate and fund university research from that perspective. So when it comes to us continuing to promote and do additional research and development support of the Air Force mission, I understand what they want and I understand how to integrate with them, I think, in sort of in a general way. So
that probably includes finding some money occasionally.
Well, it really does. You sort of understand how the budget cycles work and how different colors of money that come from different programmatic sources. Yeah. So I think that's part of it. But I think another thing is we would like to expand on this investment. The University of Tennessee, the state, the taxpayers of this great state have invested considerably in what we have here. And I think we need to move beyond just the Arnold community and go into other government customers, government clients, and other commercial activities. So, for example, 60 or so miles down the road is Redstone Arsenal. 37,000 employees on the arsenal, about $70 billion of federal funding flowing through. And as a consequence, we need to focus on expanding our capabilities to do support to a larger set of government clients and commercial space and defense partners.
Well, that does sound like something that could keep you busy for a while. And let's talk a little bit also, the last year or two has shown an increased interest in both the Air Force and now at Arnold in hypersonics. Yes. And the Air Force R&D Center has built a lab here. I'm sure you're familiar with that. And UTSI hired a prof who is also directly involved in
yes.
that development. So where is that going? What in the world is that? Sorry about that, folks. I neglected to turn my phone off. So, as I say, we were trying to mention how your background and what you're up to now figures into the increased interest in hypersonics.
Right. From what I understand, I've been here 6 weeks, of course. From what I understand, hypersonics is a major area of emphasis here in the future role of the Arnold Engineering Development Complex. And so we're expecting to provide a considerable amount of support as they carry out their expanded mission in hypersonics domain. So we have the ability to do a lot of the precursor wind tunnel testing. We can do computational modeling and wind tunnel testing, and we can develop diagnostic tools. How do you measure the phenomena in the test setup so that you can basically develop and prove the concepts? We can do that in the university setting with our graduate students and in our smaller scale, lower cost research facilities prior to going to AEDC in their larger scale systems. So we can sort of do dry run precursor testing, evaluate different concepts and test methods, and then take that to the Air Force, to their larger test capabilities there. And so that's essentially where our focus is, helping in an analytical and a computational way to understand the characteristics and phenomena that's associated with hypersonics. Now, many of the folks may not understand exactly what hypersonics is, but hypersonics is a different speed and type of flow that's beyond supersonic. So
something on the order of Mach 3.
Well, or even higher, right.
Yeah.
Supersonic means faster than the speed of sound, 1,000 miles per hour or so, I believe, depending on, how high you are above sea level. But supersonic, of course, is faster than the speed of sound. And hypersonic is a different range where the air behaves very, very differently. Because of the fast speeds and the energies involved, you change the nature of the air and you compress it in a way and it behaves very differently. And frankly, it's a new area where we're learning. We have to understand, how do we design materials to withstand these temperature extremes, and how do we design sensors to communicate through it. If you recall, the Apollo astronauts, when they would return from the moon, and the space shuttle, when it would return from orbit, they would pass through this range where they would lose their signal, and you'd see the flames going around the capsule. That's a similar phenomena you get in hypersonic flow, in that you lose the ability to transmit signals through the medium in the way that we normally do. So it's important for us to understand that for the Air Force's mission. It's also important to understand that for the Missile Defense Agency. How do you design missiles to operate in this environment? How do you anticipate defending against missiles operating in this kind of environment? So I think we here at the Space Institute are situated in a really good place to bring expertise and capabilities to help our nation in some really important ways.
Okay, very good. Well, folks, guess what? We've run out of time. We're going to have to take a short break and wrap up.
Get your news first, fast, and free with your news leader on 6 every Tuesday, Thursday, and Saturday nights at 6, 8, and 10 p.m. Local weather, sports, community calendar events, and a comprehensive look at the latest news stories and news makers as only a video news broadcast can do. Get it first, fast, and free with News Leader on Channel 6, your local information network.
We've been talking today, folks, with Dr. Mark Whorton, who is the newly appointed Executive Director at UTSI as of July. And so he's new coming into the community, and we wanted to take that opportunity to introduce him to you and your understanding of his background. And so we're glad to have him, and thank you for joining us and sharing the insights. And you have our best luck, including your commute and going beyond that. Yeah. So with that, folks, we will see you next time.